Good morning and welcome to the Select Committee on Energy Independence and Global Warming. For many members of Congress and the public, the concern about global warming may seem like a relatively new development. In fact, scientists, including those advising the U.S. government, have issued warnings about the rising concentrations of carbon dioxide in the atmosphere throughout the last 4 decades. After a report from his Science Advisory Committee, President Lyndon Johnson noted in a 1965 special address to Congress that, quote, a steady increase in carbon dioxide from the burning of fossil fuels has altered the composition of the atmosphere. In 1978, Robert White, the first administrator of the National Oceanic and Atmospheric Administration, warned that carbon dioxide emissions can have consequences for climate that pose a considerable threat to future society. More recently, the National Academy of Sciences found in a 2001 report requested by President Bush that, quote, global warming could well have serious adverse societal and ecological impacts by the end of this century. In a report issued earlier this year, U.S. science agencies concluded that climate changes are underway in the United States and are projected to grow. Administration scientists once predicted the impacts of global warming. Now they can confirm them. And unfortunately, families from New Orleans to Alaska are living with the harsh consequences. Given the upcoming International Climate Conference in Copenhagen and the continuing work on domestic clean energy legislation in Congress, an update on the Administration's view of the state of climate science is timely. In 2007, the Intergovernmental Panel on Climate Change found in their comprehensive assessment that global warming is unequivocal and that this warming is primarily due to human activities. This decade has been the hottest in recorded history, with all of the years since 2001 being in the top 10 hottest. This summer, the ocean was the warmest in NOAA's 130-year record. The extent of Arctic summer ice, sea ice for the past few years has shrunk dramatically compared to the previous 2 decades, with a reduction roughly 3 times the size of Texas. We must be aware that as the climate system warms, we risk passing certain tipping points of rapid and irreversible change. In the United States, the effects are evident. Daily record-high temperatures are being broken twice as often as daily lows. Our farms are threatened by rising temperatures, water scarcity, and pests. In the Northeast, extreme rainstorms and the risk of flooding have increased. In Alaska, villages are finding the land they call home literally melting out from underneath them as the permafrost thaws. In the West, the shrinking mountain snowpack and increasing droughts strain our water resource systems. Fortunately, after decades of warnings, President Obama is partnering with Congress to realize a new vision for America, an America freed from dependence on foreign oil and thriving as a leader of the new clean energy economy. The American Recovery and Reinvestment Act included more than $80 billion for clean energy investments to jumpstart our economy and generate new clean energy jobs. The Cash for Clunkers program took gas guzzlers off the road. Fuel economy standards were raised for model year 2011 cars and trucks, saving drivers money and spurring companies to develop more efficient, affordable vehicles. In June, the House passed the Waxman-Markey American Clean Energy and Security Act. This legislation that will put us on a pollution-cutting path and at the same time create millions of new jobs, making America the global leader of the clean energy economy. The Act will also create a national climate service that will provide decision-makers with vital climate science information. As we move forward, we must continue to stay abreast of the most recent findings and to ground our policy in the latest climate science. Our witnesses today, Dr. John Holdren, the President's Science Advisor, and Dr. Jane Lubchenco, Administrator of the National Oceanic and Atmospheric Administration, will help us do that. Now I would like to turn and recognize the ranking member of the committee, the gentleman from Wisconsin, Mr. Sensenbrenner.
Well, thank you very much, Mr. Chairman. And what we've just heard from the Chairman is a case of denial on what's happened recently. Sound science depends on sound policy, or sound science policy depends on sound science. When the science itself is politicized, it becomes impossible to make objective political decisions. Scientific policy depends upon absolute transparency. As policymakers, we should all be concerned when key climate scientists write in private correspondence that they found a trick to hide the decline in temperature data documented in climate studies. Less than 2 weeks ago, some 160 megabytes of data containing over 1,000 emails, including one from today's witness, Dr. John Holdren, and 2,000 other documents from the Climate Research Unit at the University of East Anglia in the UK were posted on the Internet. While the emails don't undermine everything we know about climate change, their contents are shocking. And in the words of Clive Cook, senior editor of the Atlantic Monthly, a columnist for National Journal, and a commentator for Financial Times, the stink of intellectual corruption is overpowering. The temperature records from the climate research are one of only 3 major data sets, which considerably overlap and which have been used as the bedrock for the assessments by the Intergovernmental Panel on Climate Change and the United States Global Change Research Program. The data set in question is the basis for virtually all peer-reviewed literature. The document shows systematic suppression of dissenting opinion among scientists in the climate change community, intimidation of journal editors, and a journal who would deign to publish articles questioning the so-called consensus, manipulation of data and models, possible criminal activity to evade legitimate requests for data and the underlying computer codes filed under Freedom of Information Acts, both in the U.S. and in the United Kingdom, and demonstrate that many climate scientists and proponents of climate change legislation have vested interest, a clear conflict of interest. Those with the most to gain from climate change have tried to dismiss these emails as out of context. So I'm going to read a few examples. From Kevin Trenberth, quote, "The fact is that we can't account for the lack of warming at the moment, and it is a travesty we can't. The series data shows that there should be even more warming, but the data are surely wrong. Our observing system is inadequate," unquote. From Phil Jones, quote, "I've just completed Mike's nature trick of adding in the real temps to each series for the last 20 years, that is from 1981 onwards, and from 1961 for Keith's to hide the decline," unquote. From Andrew Manning, quote, "I'm in the process of trying to persuade Siemens Corporation to donate me a little cash to do some CO2 measurements here in the UK. Looking promising, so the last thing I need is news articles calling into question again observed temperature increases. I thought we'd moved the database beyond this, but it seems like the skeptics are real diehards," unquote. From Keith Briffa, quote, "I tried hard to balance the needs of the science and the IPCC, which are not always the same. I worried that you might think I give the impression of not supporting you well enough while trying to report on the issues and uncertainties," unquote. From Phil Jones, quote, "I'm getting hassled by a couple of people to release the CRU station temperature data. Don't any of you 3 tell anybody that the UK has a Freedom of Information Act," unquote. From Michael Mann, quote, "This was the danger of always criticizing the skeptics for not publishing in the peer review literature. Obviously, they found a solution to that. Take over a journal. So what do we do about this? I think we have to stop considering climate research as a legitimate peer-reviewed journal. Perhaps we should encourage our colleagues in the climate research community to no longer submit to or cite papers in this journal. We also need to consider what we tell or request of our more reasonable colleagues who currently sit on the editorial board, unquote. From Phil Jones, quote, if anything, I would like to see climate change happen so the science could be proved right regardless of the consequences. This isn't being political, it's being selfish, unquote. Now, these emails show a pattern of suppression, manipulation, and secrecy that was inspired by ideology, condescension, and profit. They read more like scientific fascism than scientific process. They betray economic and ideological agendas that are deaf to disconforming evidence. Hopefully, this scandal is the end of declarations that the science is settled and the beginning of a transparent scientific debate. The seriousness of this issue justifies additional consideration. The majority did not permit us to invite a witness to this morning's hearing, and therefore I am requesting a minority day of hearings and am filing with the Chairman a letter signed by all 6 of the Republican members of this Select Committee pursuant to Rule 11J1 of the House of Representatives to have a minority day of hearings. And I yield back the balance of my time.
I thank the gentleman very much. The hearing today is for the purpose of hearing from administration witnesses. In my 34 years here, whether it be a Democrat or Republican administration, I had no memory of another witness sitting with administration officials at the time of their testimony. But I will.
Will the gentleman yield?
I will be glad to yield.
When I was chairman of the Judiciary Committee, I did not allow anybody to sit with cabinet level or cabinet rank level witnesses, but there were other people who sat with administration witnesses and in many cases contradicted them, including witnesses that were proffered by the Democratic majority on the Judiciary Committee.
Well, in the 15 years that I have chaired a committee here in the House, I have always offered as a courtesy to the Reagan administration, to the first Bush administration, and to this second Bush administration, the courtesy of having their administration officials sit and make their presentation. And that's how I've conducted myself since 1981, chairing committees, and I extended that courtesy through 3 Republican administrations. So that is my own personal history. And I did not think it was appropriate to have another witness sitting with these representatives of President Obama, since I did not allow that to happen with President Reagan or the 2 Bush presidencies. But I will be more than willing to discuss future hearings with the gentleman and the minority if they would like. Let me now turn and recognize the gentlelady from South Dakota.
Thank you, Mr. Chairman. I don't have an opening statement. I'll reserve for questions.
Let me recognize the gentleman from Colorado.
Well, thank you, Mr. Chairman. Good morning. I'm looking forward to hearing the testimony today. We have a complex problem before us today, and I'm interested to hear where we are in the science. I also want to know what we can do better to adapt our communities and practices to prepare for the anticipated climate changes. The information found in the recently released report entitled Global Climate Change Impacts in the United States is quite comprehensive. However, I'm glad to see that both of you in your testimony say that we need more regional specific information to help decision makers plan in the future. Colorado and the 3rd Congressional District has rich agricultural resources and millions of acres of forest. We also depend in large part on a limited amount of water for our survival. I'm concerned about how we can effectively prepare for the changes you predict. As I mentioned, water is one of the natural resources my district heavily depends on. While we have a lot of snow in the mountains, the valleys see very little water. And I'm very proud of the $5 million appropriation for the Arkansas Valley Conduit that was approved this year. That's the first round of conduit funding, which will be used for the environmental analysis and planning and design. The Arkansas Valley Conduit is designed to provide clean drinking water to approximately 40 cities, towns, and water providers in the lower Arkansas Valley. These communities are in dire need of a source of water that will help them comply with the Clean Drinking Water Act in a manner that they can afford. Every community that will receive water from the conduit is currently rated below the 85% level of average household income. The roots of the Arkansas Valley Conduit stretch back to 1962 when the conduit was authorized by Congress as part of the Frying Arkansas project. And the reason that I bring this up is that it took over 45 years, close to 47 years, to get the funding for this critical project. And if it takes that long for something this critical, we need to better prioritize needs and support for our communities. I'm a farmer. Agriculture is a cornerstone of my life and also the district that I represent. In my district, we produce wheat, potatoes, barley, beef, and many other crops. Agriculture is one of the top 3 economies in the district. The demand to produce more food will only increase as the population increases. And according to the report I mentioned before, climate change has the potential to negatively affect growth and yield of many crops, as well as increase populations and vigor of a variety of weeds and insect species. If this is true, how soon do we anticipate these changes, and how do we accommodate them? We've already seen the effects of warmer weather and drought in our forests. Over 2 million acres of forests in Colorado are dead because of the mountain pine beetle. This epidemic will change the landscape of Colorado for decades. We need to manage our forests for resiliency in the future so that they can withstand the changes in weather. So I do look forward to your testimony today, and I want to thank you for being with us. I yield back.
Great. Gentleman's time has expired. The chair recognizes the gentleman from Arizona, Mr. Shattuck.
Thank you, Mr. Chairman, and I apologize. I have another hearing, so I will have to leave for a portion of my time here. But I want to begin by noting something that I think everyone in the room knows, but nobody wants to acknowledge. It is that there is an elephant, a large elephant sitting in the middle of this room. You can ignore it if you like. Members of the minority can ignore it if they like. Members of the majority can ignore it if they like. Members of the staff or the press or the audience can ignore it if they like. But that elephant is the credibility of the entire scientific community, which has told us that the science behind man-made global warming is resolved. Make no mistake about it. When you read in the emails which have been made public recently that science was politicized, that its proponents were unwilling to release their data, that they were unwilling to have their theories tested, that they were threatened by anyone and everyone who dared challenge them, when you realize they were that insecure, then you have to understand that their credibility, the entire credibility of the theory, is placed on the line. Now, that does not mean it cannot be rehabilitated, but it's interesting to me, those who have not simply accepted the claim of man-made global warming, man-caused global warming, have been called deniers. I would suggest that when the White House reads of these emails and the press secretary for the White House steps forward and says they mean nothing, the science is already resolved, maybe the term deniers best applies to those in that position. Public policy is a difficult business. It is hard for those of us who sit on this side of the dais to make decisions, and to make those decisions in the best interest of the nation. At times we are asked to call upon our citizens to sacrifice, to pay more in taxes, to lose jobs, to give up lifestyle, to pay more for energy. We simply cannot do that when the evidence we are supposed to be basing our decisions upon has been clearly politicized, when there is a grave question about its credibility. Until we address the evidence, until we address the elephant in the center of this room and resolve the questions raised by the appalling emails which have been made public, it is impossible for this Congress to set public policy in this area and to make the people of America accept and give of the sacrifices they will have to give to make the changes called for by the legislation that's before this Congress. Anyone who thinks that those emails are insignificant, that they don't damage the credibility of the entire movement, is naive. We cannot expect people in a free society to make sacrifices on anything other than hard evidence. Here, that hard evidence has to be hard evidence that, in fact, global warming is caused by man, and that the sacrifices called for in the legislation are necessary. These emails repeatedly shown that the scientists involved who authored them, the scientists who are behind global warming, or the argument that global warming is caused by man-made factors, The emails demonstrate that they are afraid to reveal the facts, that they have been unwilling to have their theories tested, that they have been unwilling to provide their data, and they are unwilling to have their theories openly challenged. Now, because their own defenses and justifications for hiding these facts and their data has changed so many times, we now learn that maybe the data does not even exist. It is critical for this Congress to find out and to get to the bottom of the question of what the elephant in the room is and what the real science is, and whether money and politics has eroded the credibility of that science. Thank you, Mr. Chairman, and yield
Gentleman's time
back.
has expired. The chair recognizes the gentleman from Oklahoma, Mr. Sullivan.
Thank you, Mr. Chairman.
Excuse me, I did not see the gentlelady from Michigan. Chair recognizes the gentlelady from Michigan, Ms. Miller.
Thank you, Mr. Chairman. I appreciate you having this, this hearing. I think it's an interesting title of the hearing. The state of the climate science, I think, is particularly interesting in light of what is happening. And I'd like to associate myself with the remarks made by the ranking member and the others on the minority side here of the panel. I come from the state of Michigan. We have the highest unemployment in the nation. Everybody is well aware of that. As well, we derive about 2/3 of our electricity from coal. And for these reasons and others, I really looked very closely at the cap-and-trade legislation and finally decided that it would just be so devastating for Michigan's economy and our nation that I could not support it. But, you know, we had been told that we had to pass this legislation because the debate was over, the science was absolute, the science is incontrovertible about climate change, and regardless of what it means economically to us, we need to do this to protect our environment and our very way of life. And, you know, particularly hard hit with the cap-and-trade would be states like Michigan. In fact, the Detroit News editorialized that the cap-and-trade legislation, as they said, would be a dagger through the heart of Michigan's economy. So when I saw this noticed, this committee hearing noticed, I was very enthusiastic because I thought we were going to be able to talk this morning about what many people are calling Climategate, which I think is an appropriate analogy because it is totally a cover-up, what is happening. And as the ranking member has, I won't go through any of the emails, I had a list of them here as well, but he certainly has articulated many of them already. But I thought we were going to have a hearing about that, and if we're not, I would mention that I had also respectfully sent a letter earlier this week to the chairman and the ranking member to ask this committee to have a hearing. I think it is important that the committee investigate these emails and what has happened in Climategate. I think transparency is the most appropriate thing, and I think it is very important that we have transparency and that we look at these things, because certainly the central arguments about man-made climate change is certainly in question. I think the science is not settled, and the debate is raging around the United States and around the globe right now, particularly on the eve of Copenhagen. And I would simply just mention one other thing, if I could, Mr. Chairman. We did have a hearing just a couple of months ago about a dozen fraudulent letters that were sent during the cap-and-trade legislation, and I thought that was an appropriate thing. But certainly if we could have a hearing about a dozen fraudulent letters, we could have a hearing in this committee about Climategate. And thank you, and I yield back.
Gentlelady's time has expired. The chair recognizes the gentleman from Washington State, Mr. Inslee.
Thank you. I understand that those people who have been refusing to accept science for years are enjoying their moment talking about language from some emails that were taken out of context. I understand their enjoyment to continue to deny obvious facts. And if you could take those emails and chop them up and put them in a C-130 and sprinkle them over the Arctic and stop the Arctic from melting, it would be a good thing, but that won't happen. If you could take those emails and chop them up into fairy dust and sprinkle them over the Greenland ice cap and stop the accelerated melting going on there, that would be a good thing, but that won't happen. And if you could take those emails and chop them up and sprinkle them over the oceans and stop the incredible ocean acidification that is so damaging, that would be a wonderful thing, but that won't happen. The fact of the matter is plain and clear for anyone who is willing to dispassionately look at the evidence. And I would encourage for those who want to look at the most recent evidence on this to take a look at a group called the Copenhagen Diagnosis, or find it www.copenhagendiagnosis.com. It is an update of the IPCC information. And the update is that since 2007, the sequelae of both ocean acidification and global climate change have been either accelerating or at least worse than was predicted in the IPCC report. The global deniers are right. The 2007 IPCC report was not entirely accurate. And it was not entirely accurate because this problem is worse than the last IPCC report indicated. Surging greenhouse gases are worse than predicted. Recent global temperatures demonstrate human-based warming. The acceleration of melting ice caps in the Arctic is worse than expected. The rate of decline in glaciers is worse than expected. The disappearance of the Arctic summer ice is worse than expected. The current sea level rise estimates are worse than expected in the IPCC 2007 report. So the point of the current science is that what we had in 2007 is indeed out of date. This problem is worse than expected. And I'll just comment on one thing that I learned. Sometimes you can learn things from silence as well as people talking. I was at my old school at the University of Washington last week, and we were talking about this issue, and this young man stood up, and he was a global climate change denier, and he was having field day with some email language that he thought showed some massive conspiracy by the Trilateral Commission or something to take over the Earth. And I just said, look, if you're right, and if there's no global warming, if you're so right, what are you going to do about ocean acidification? What do you say about that? And he was silent. And that silence speaks volumes. If people over here want to deny clear science about global warming, they cannot deny the fact that the oceans are becoming acidified, that no reputable science anywhere in the world recognizes it as happening caused by CO2 going into the atmosphere, going into a solution acidifying our oceans. So I just say the science is clear. I wish it was otherwise. Life would be easier, but this is the challenge of the ages. Thank you.
Great. Gentleman's time has expired. The gentleman from Oklahoma, Mr. Sullivan, is recognized.
Thank you, Mr. Chairman. I appreciate you holding this hearing today, but unfortunately, we were not allowed a minority witness. Yesterday, I was pleased to sign on to a letter by Ranking Member Sensenbrenner and my Republican colleagues on this committee requesting a day of hearings to consider the scientific evidence for climate change, the observed and anticipated impacts of climate change, and the key areas of further research. I hope you will honor this request as we are on the eve of the Copenhagen Climate Conference. In light of the recent disclosure of emails between several prominent climatologists revealing possible deceitful manipulation of important climate data uncovered at the world-leading climate change unit at the University of East Anglia in England, I think it is imperative that we launch an investigation into this issue and re-examine all the scientific evidence surrounding climate change. With the United Nations Climate Change Conference in Copenhagen set to begin in less than a week, we need to have all the facts before us as we consider whether this is in the United States' best interest to agree to a binding international climate treaty. For the record, I am opposed to any climate treaty that does not recognize the right of every country to protect its own national energy interest and would place the United States at a competitive economic disadvantage worldwide. I'm interested in learning from our panel today whether or not they would support an independent investigation into the climate change unit emails and whether or not these emails raise concerns about the integrity of the scientific process. I yield back my time.
Great. Gentleman's time has expired. All time for opening statements from the members has been completed. We'll now turn to our very distinguished witnesses. Our first witness is Dr. John Holdren. He serves as assistant to President Obama for Science and Technology. He is the director of the White House Office of Science and Technology Policy and co-chair of the President's Council of Advisors on Science and Technology. He was a professor at Harvard. He was the director of the independent nonprofit Woods Hole Research Center. He is a member of the National Academy of Sciences. He has received the MacArthur Foundation Prize, the Genius Award. We welcome you, sir, before our committee. Whenever you're ready, please begin.
Mr. Chairman, I would request that the witnesses be sworn before they testify today.
the committee will stand in brief recess. The gentleman, the ranking member of the committee has made a request to have the witnesses sworn in. The chair has a right to, in his discretion, to make that determination, and I do not think it is necessary. I think that the administration is going to testify truthfully before our committee today, and we will operate under that premise, and we will begin the hearing with the testimony of Dr. Holdren, the President's Science Advisor.
Thank you, Chairman Markey, Ranking Member Sensenbrenner, members of the committee. I do thank you for inviting me to testify on this timely and important topic today. I had planned to summarize in my brief oral statement the written statement that I provided to the committee addressing current and projected impacts of climate change and also climate science research activities, needs, and products, as the letter of invitation requested. But given the emphasis in some of the opening comments on the emails, I'm going to divert from that program and say a few words about the emails, and then finish with the concluding part of my original oral statement. The emails are mainly about a controversy over a particular data set and the ways a particular small group of scientists have interpreted and displayed that data set. It's important to understand that these kinds of controversies and even accusations of bias and improper manipulation are not all that uncommon in science, in all branches of science. The strength of science is that these kinds of controversies get sorted out over time as to who is wrong, who is right, and how much it matters by the process of peer review and continued critical scrutiny by the knowledgeable community of scientists. Of course, openness in sharing of data and methods is very important to this process. And as I think you all know, this administration is a strong proponent of openness in science and in government. And Administrator Lubchenco will have some things to say about public access to the climate data maintained by her agency and maintained by other agencies in the United States. In this particular case, the data set in question and the way it was interpreted and presented by these particular scientists constitute a very small part of the immense body of data and analysis on which our understanding of the issue of climate change rests. The question being addressed by these data was, have there been natural periods of warming in the past, in the last 1,000 or 2,000 years in particular, that have been stronger than the episode now being experienced? That's an interesting question. And because of the controversy around it at the time most of these emails were written, that is, in the early 2000s, the National Academy of Sciences undertook a thorough review of all of the relevant data sets and all of the methods of analysis, not just the data set used by these particular authors or the methods used by these particular authors. The National Academy's report on this matter was published in 2006, and it concluded that the preponderance of available evidence points to the conclusion that the last 50 years have been the warmest half-century in at least the last 1,000 years, and probably much longer. There is, and there will remain after the dust settles in this current controversy, a very strong scientific consensus on the key characteristics of the problem. Global climate is changing in highly unusual ways compared to long experienced and expected natural variations. The unusual changes match what theory and models tell us would be expected to result from the very changes in the atmosphere that we know have been caused by human activities, above all burning fossil fuels and tropical deforestation. Significant impacts on human well-being from these changes in climate are already being experienced, and continuing with business as usual in the fossil fuel burning and tropical deforestation activities that are the largest contributors to these changes in the atmosphere is highly likely to lead to growth of the impacts to substantially unmanageable levels. The details in support of those propositions are in my written testimony. Let me turn to the closing part of my remarks. I've tried to indicate in the written testimony and here that we in fact know a great deal about global climate change, what its causes are, how it works, what its impacts are and are likely to become. But of course there is more to learn, and the federal government is doing a lot in support of the research needed to learn more and its translation of that research into products our society can use to better cope with climate change. But there again, we need to do more. With that said, I emphasize again that in my judgment, and that of the great majority of other scientists who have seriously studied this matter, the current state of knowledge about it, even though incomplete, as science always is, and even though controversial in some details, as science almost always is sufficient to make clear that failure to act promptly to reduce global emissions to the atmosphere of carbon dioxide and other heat-trapping substances is overwhelmingly likely to lead to changes in climate too extreme and too damaging to be adequately addressed by any adaptation measures that can be foreseen. The United States, as the largest contributor to the cumulative additions of anthropogenic, that is, human-caused greenhouse gases to the atmosphere since the beginning of the Industrial Revolution, and still today the second largest emitter after China, and as the world's largest economy and preeminent source of scientific and technological innovation, we have the obligation and the opportunity to lead the world in demonstrating that the needed emissions reductions can be achieved in ways that are affordable and consistent with continued economic growth, that create new jobs, and that bring further co-benefits in the form of reduced oil import dependence and improved air quality. President Obama is going to Copenhagen to underline that his administration is fully committed to assuming this leadership role. The administration obviously will need the support of the Congress in delivering on this promise, and I'd like to thank you, Chairman Markey, and this committee for your own leadership in this critically important domain. I thank you as well for your attention.
Thank you, Dr. Holdren, very much. Our second witness is Dr. Jane Lubchenco. Dr. Lubchenco is the Undersecretary of Commerce for Oceans and Atmosphere and the Administrator of the National Oceanic and Atmospheric Administration. She has been a distinguished scholar on these issues. She is one of the most highly cited ecologists in the world, a member of the National Academy of Sciences, and similarly a recipient of the MacArthur Fellowship, as was Dr. Holdren. We welcome you, Dr. Lubchenco. Whenever you are ready, please begin.
Thank you, Chairman Markey. Ranking Member Sensenbrenner, members of the committee, I greatly appreciate the opportunity to testify today. I appreciate your interest in the science of climate change and the spectrum of climate sciences and services needed in this country and abroad to make critical decisions for now and for the future. As President Obama said to the National Academy of Sciences, science is more essential for our prosperity, our security, our health, our environment, and our quality of life than it has ever been before. As head of NOAA, one of the nation's premier science, service, and stewardship agencies with responsibilities for both oceans and atmosphere, I strongly support a focus on science-based decision-making. Science can help inform the understanding of opportunities and challenges presented by climate change. Through sustained federal and extramural partnerships and collaborations, the nation has made very significant progress in our understanding of climate change. The core capabilities needed to understand the state of the climate and make projections about future climate and associated impacts include integrated and comprehensive observing systems on land, in the oceans, the atmosphere, and space, research into the physical system and its interconnectedness to the human, ecological, and biogeochemical systems, modeling from intra-seasonal to multi-decadal to centennial timescales, and a means to assess and communicate the climate information about current and future impacts. 3 entities, the Intergovernmental Panel on Climate Change, the Ipcc, the U.S. Global Change Research Program, and the National Academy of Sciences, have all published several peer-reviewed syntheses of the latest climate science findings and associated impacts. NOAA scientists have played a significant role in all of these assessments. For example, NOAA played a lead role in the development of the U.S. GCRP's global climate change impacts in the United States report, a landmark assessment report that Dr. Holdren and I proudly announced just this last June. And NOAA scientists made up 73% of the federal authors in the Ipcc's 4th assessment report for Working Group 1, the basis of the physical understanding of climate. Since the Ipcc process began in the late 1980s, a wealth of global scientific information has cumulatively provided stronger and stronger evidence that the Earth is warming and that humans are primarily responsible. As stated in the Global Change Impacts 2009 report, global warming is unequivocal and is primarily human-induced. This warming can be seen in increases in global average surface air and ocean temperatures, widespread melting of snow and ice, rising sea levels, and changes in many other climate-related variables and impacts. Most of the observed increases in global temperatures since the mid-20th century are due primarily to human-induced increases in concentrations of heat-trapping greenhouse gases. When I served on the very first National Academy of Sciences study on policy implications of global warming in the 1980s, we talked about what human-induced climate change might look like at some point in the future. Today, we know that it's happening now. We are already seeing the effects of climate change on our landscapes, our neighborhoods, our farms, as well as our forests, oceans, and mountains. We are able to measure these changes through significant advances in our observing systems over the last 20 to 30 years, many of which are the result of NOAA's responsibility and innovation, and through collaborative global and national efforts to provide systematic and widespread monitoring of the climate system and associated environmental and social changes. As a result, we have a much better understanding of present and expected impacts of climate change. Widespread climate change impacts are occurring now and are expected to increase. I emphasize that climate change is not a theory. It is a documented set of observations about the world. A key element of the U.S. Global Change Research Program emphasizes the importance of multiple independent analyses and data sets to quantify uncertainties. And therefore, we have the benefit of this policy when it comes to global change analyses. The NOAA data used in the Ipcc report are open and available, openly available. They are used heavily in the Ipcc results of temperature change, similar to other major global data sets maintained by other U.S. agencies such as NASA, and that maintained by other countries such as the United Kingdom. So what are these data sets? What do these observations tell us about climate change? What do we know with certainty about trends to date, and what do we think is highly likely in the future? Global average sea surface temperature has risen by 1.5 degrees Fahrenheit since 1900 and is projected to rise another 2 to 11.5 degrees by 2100. The current atmospheric carbon dioxide concentration is estimated at about 385 parts per million, which is higher than the highest point in the last 800,000 years. Temperatures in the next couple of decades will be primarily determined by past emissions of greenhouse gases, but increases thereafter will be primarily determined by future emissions. Current observed global emissions of carbon dioxide emissions are beginning to exceed even the upper range of the 2007 Ipcc scenarios. There is strong agreement and much evidence that with current climate change mitigation policies and related sustainable development practices, global greenhouse gas emissions will continue to grow over the next few decades. As we continue to learn more about the climate system, I would like to reiterate the importance of looking at the Earth system holistically and understanding the interconnected nature of the ocean, atmosphere, and terrestrial systems. In particular, I want to emphasize the importance of continuing our work to better understand the oceans and the potential impacts of climate change on them. I believe we've been championing the notion that we do not have but urgently need a strong focus on ecosystem-based science to inform decisions about adapting to climate change. An ecosystem-based approach also provides a broad array of possible tools for adaptation to climate change. Climate change interacts with and exacerbates other changes ranging from overfishing to nutrient pollution to invasive species and habitat destruction. Removing one or several of these stresses is likely to enhance the resilience of the system to other stresses. Equally important is the need to acknowledge that we are likely to see surprises as human actions disrupt many fundamental biogeochemical and ecological processes. The now routine appearance of dead zones, areas of low or no oxygen on the coasts of Oregon and Washington during the summertime, is an example of an unanticipated change with possibly serious consequences. What does managing with the expectation of surprises look like? These are rich areas for future research and management alike. And finally, ocean acidification, which I call the equally evil twin of climate change, provides yet another major threat to coastal and ocean ecosystems. Getting a better handle on rates of change in ocean chemistry and the consequences to marine biota are high priorities. The seemingly persistent hypoxic events off the Pacific Northwest coast and this increasing corrosiveness of the water because of acidity are two examples of potential consequences from increasing CO2 in the atmosphere. In addition, climate change can exacerbate other human-induced stresses to aquatic systems, such as those caused by nutrient loading, invasive species, and overfishing. As water resources are stressed, coastal areas are at increasing risk from sea level rise, inundation, and storm surge. North Atlantic fish populations are shifting north due to warmer oceans, and the threat to human health increases due to heat stress, air quality, and waterborne diseases. We must continue to enhance our scientific capacities, including research, observation, modeling, predictions, projections, and assessments, to ensure that we are providing policy and decision makers, planners, and the public with the best possible science-based information to take on the challenges and opportunities posed by climate change. Thank you again, Mr. Chairman, for the opportunity to provide you with this review and update of the climate change science and ocean acidification. NOAA looks forward to continuing to provide national and international leadership in collaboration with our partners to ensure the solid foundation of climate science and service necessary to inform critical decisions about our future as a nation and a global society.
Thank you. Now, I know you want to give us a brief demonstration of the science, and if you would like, could you please do that at this time, and then we will go to questions.
Okay, thank you very much. I appreciate that. What I'd like to do is just start here briefly and then move over and describe what I would like to share with you. I greatly appreciate the opportunity to not only present the oral testimony that I did, but to provide a demonstration of some basic scientific concepts of ocean acidification. Ocean acidification is a global-scale change in the basic chemistry of the oceans that is underway now as a direct result of the increases of CO2 in the atmosphere. We are just beginning to understand the impacts of ocean acidification on life in the ocean. The moniker osteoporosis of the sea gives you a hint about some of its impacts. The basic chemistry of ocean acidification is understood and is not controversial. Here are three basic concepts. Number one, the chemistry of the oceans is dependent upon the chemistry of the atmosphere. More CO2 in the atmosphere means more CO2 in the ocean. Number two, As CO2 from the air is dissolved into the ocean, it makes the oceans more acidic. The resulting changes, number 3, in the chemistry of the oceans disrupt the ability of plants and animals in the sea to make shells and skeletons of calcium carbonate. And those chemical changes also dissolve shells that are already formed. So who in the oceans is affected by this? Any plant or animal that has a shell or a skeleton made of calcium carbonate. The hard parts of many familiar animals, such as oysters, clams, corals, lobsters, crabs, such as those on this table, and those on the posters, are made of calcium carbonate. Many microscopic plants and animals at the base of the food chain also have calcium carbonate shells or skeletons. Some of these microscopic plants and animals are so abundant that when they die, they form massive deposits as they accumulate on the seafloor. The famed White Cliffs of Dover are a familiar example of calcium carbonate, or chalk, deposits, the skeletons of microscopic organisms. More acidic ocean water is corrosive to all of these calcium carbonate shells and skeletons, but let me focus on 2 quick examples. Number 1, corals that provide the fundamental structure for the world's treasured coral reefs make their skeletons with calcium carbonate. More acidic ocean water makes it harder for corals to make their hard parts. If the ocean becomes too acidic, coral reefs may well disappear. Pteropods, number 2, also called sea butterflies, are small shelled animals about the size of a lentil bean. They occur in the millions off the coast of my home state of Oregon, but also throughout the world's oceans. They are a key or the primary source of food for juvenile salmon and many other fish around the world. Pteropods are particularly susceptible to increasingly acidic ocean water, as you'll see in a moment. And I mention them in part because they illustrate the broader consequences of disruption of one part of the ocean ecosystem reverberating throughout other parts of the system, potentially affecting jobs, food security, tourism, and more. The severity of ocean acidification's impacts is likely to depend in part on the interaction of acidification with other environmental stresses, such as rising ocean temperatures, overfishing, and pollution from the land. Early evidence suggests that some species are better able to thrive in increased acidity, but the adaptability of most organisms to increased acidity is unknown. While our understanding of ocean acidification's impacts are still unfolding, the basic science of how the ocean is acidifying and the effects of increased acidity on some marine organisms is well known. And I'd like to now demonstrate 2 of the basic concepts that I just mentioned. The ocean does a great service. The ocean does a great service by absorbing tremendous amounts of carbon dioxide from the atmosphere. And in fact, the oceans have absorbed already about 1/3 of the carbon dioxide that humans have contributed to the atmosphere over the last 2 centuries. This greatly reduces the impact of these heat-trapping pollutant gases on the Earth. But the carbon dioxide that is absorbed by oceans changes the chemistry of seawater, making it more acidic and more corrosive. When carbon dioxide dissolves in water, it forms carbonic acid, making the water more acidic. And to illustrate how this occurs, I brought a vessel of water, some common laboratory blue dye that changes color as the acidity in the solution changes, and some dry ice, which is simply compressed, frozen carbon dioxide. So I will first squirt some of this dye into the pitcher of water. Swirl it around a little bit. Actually, I was going to do that in this, wasn't I? I will put it in here. Thank you, Jen. Okay, I'm just going to add a little more dye here.
Why don't
Thank
you
you.
move that microphone over?
Do we need the microphone? Can I? I've used tap water to demonstrate this concept, but the same phenomenon happens with seawater as with tap water. As it absorbs carbon dioxide, the carbon dioxide changes into carbonic acid and becomes more acidic. Over the last 2 centuries, the oceans have now become 30% more acidic because of the CO2 that they have absorbed from the atmosphere. The second demonstration that I want to do for you involves, I'm going to set this aside. Thank you. Illustrates another very important principle, and that is that calcium carbonate, which is the basic building block of all of these calcifiers, oysters, clams, mussels, oysters, those are all made of the same stuff as chalk. Now, chalk, in the olden days, when I was growing up, most chalk that we would use in school was pretty pure calcium carbonate. Today, other substances have been added to it to make it less dusty, less breakable, etc. So if you want to try this at home, you need to get almost pure chalk, which is what this is. And what I'm going to do is to show you what happens to chalk or other types of calcium carbonate when it is in regular water, when it is in water, half vinegar solution, which is more acidic. As you know, vinegar is a weak acid, so I've combined water and vinegar there. And in this container, this is all vinegar. And so we have an increase in the amount of acidity from normal water, half vinegar, and pure vinegar. And what I want you to notice is that when we put calcium carbonate chalk into the water, and the same would happen if you put it into seawater, nothing happens. This is the way the ocean has been for a long time. Shells are fine in water, they don't dissolve. If you put chalk into half water, half vinegar, you can see some bubbling start to happen. That is the calcium carbonate that is beginning to dissolve in the weak acid and releasing carbon dioxide, bubbles of carbon dioxide. And if we put the chalk into pure vinegar, you can see that it starts bubbling much more quickly, much more rapidly, and is in fact dissolving much more rapidly. So here we have just a couple simple demonstrations that illustrate some very basic principles of what happens in oceans as they absorb the carbon dioxide that we have put into the atmosphere. I want to be crystal clear here. The ocean will never be as acidic as vinegar is. I have used it here simply as a visual demonstration of what happens when you increase the level of acidity in a solution, what happens to calcium carbonate shells. To show you what actually happens in seawater, the seawater that is projected to be affected by increased CO2 by the end of this century, I have a video clip